Welcome to this next section. This is question 2 of AQA AS Physics, past paper June 2010. Now it says for 2A, it says explain why an inclined plane rather than a free fall will produce data which is valid when investigating the motion of a falling object. Basically, it takes away the effects of air resistance, so you're pulling it down, but it doesn't take them away, but the air resistance would slow it down, so it improves your reading. If you do it on an inclined plane, you can measure distance more accurately. There's your 2 marks. I didn't spend too long on that because hopefully it is quite self-explanatory. 2B. Right, I'm going to draw out the thing that it gives you. So it gives you something like this. Theta equal to 1.8 degrees. Gives you the trolley. Gives you a block. And it says the mass of the trolley is 0.2 kilograms. Now we know the weight is equal to mg, so W equals mg. We know the value of g, 9.81. The mass is 0.2 kilograms as we're told, so 0.2 kg times 9.81. It gives us a weight of 0.06 newtons. Got it? Which it asks us to find in the first question. So that's the first part. Tick, done. You need to put W equals mg, put in your facts, what you've got down, you put your mass in, label your mass. You don't have to draw that out, it's given to you in the exam, so I just drew it out so you can understand where I got it from. Right. So, the next part says calculate the initial acceleration down the slope. Now you may be sat there thinking, well, we've not got the initial velocity, we've not got the final velocity, we don't know the time, so how on earth are we going to work out the acceleration? We can't use Suvat equations. Well, the acceleration wouldn't be constant, so we can't use Suvat equations, plus the fact we'd have to consider the angle, which is 1.8 degrees of theta. So if you don't get what I'm going to do next, you can just visit the one of the tutorials about the acceleration down blocks, or force equals mass times acceleration video, which should be all up and working for you now. So I think I'll draw, hang on. So we worked out mg. Now mg is the force. Now it's a force perpendicular, sorry, parallel to the slope, because it's acting, yeah. So we've, oh wait, sorry, no, that 2b part 1. That's where I was getting confused. Right, so for 2b part 1, we've worked out the weight. Now we need to work out the weight acting down the slope. That isn't what, like 6 meters. So we know that W equals mg. Now mg sine theta is parallel to the slope. So mg sine theta that's right. Mg sine theta equals the weight along the slope, and we know mg is equal to W, so W sine theta is equal to I'm just going to write it as in 0.2 times 9.81 times sine of 1.8 equals 0.06. Sorry, I knew when I did it on my calculator it came out to be 22 newtons for when I times 9.8 by 0.2. Yeah, so that's the and it says calculate the initial acceleration down the slope. Now this is the resultant force mg sine theta. There's no pulling back forces, so we can just assume that the only force acting down the slope is a weight parallel to the slope. So we know that's mg sine theta. Now that's the resultant force, as we've said, as weight's a force, and the force acting down the slope is a force. That's the only force, so it's the resultant force, as we don't need to take anything away from it. Now, as we know from Newton's second law of motion, force equals mass times acceleration. So is that's the resultant force mg sine theta. You can put that in, equals mass times acceleration. Now, you notice I've not put any values in yet, which is what I'm going to do now. So we can simply put 0.06 newtons. We don't need to faff around with all this again, because we've already worked it out. 0.06 newtons equals mass, which is 0.2 kilograms, 0.2 kg times A. And I rearrange this to get A is equal to 0.06 newtons over 0.2 kilograms. And that gets us A of approximately 0.31 meters a second. That's the two significant figures, but you should always give it to in an exam. So that's the initial acceleration. So that's that bit done and dusted. Now we go on to the next part of question 2, which is a bit of a different part. But I'm going to leave the diagram on there, because it's still going from the diagram, but we've got pendulum involved this time. I'll just rub that out with my hand actually. And 2. Right, next question, question 2D. I'm going to draw out, I'm not going to necessarily draw out the graph to scale, I'm just going to draw out the table and we'll go from there. So T, this is the number of pendulum swings, so it goes up to 4, 1, 2, 3, 4. This is the distance on the right, I'll just put D, and that goes 0.29, and this is in meters, 0.29 meters, 1.22, 2.7, 0, 4.85. Right, so there are all in meters. Now what does the question actually ask? Well, it's got a graph, sorry, I drew this graph. So it goes something like that. So you got D on the side and T on the bottom. Obviously I've said that's not labelled. No, it says from the graph on page 6, which is my scum drawing there, it says that what would you conclude about the motion of the trolley? Now, there's 2 marks to this, so you don't need to go into such great detail, but you just say, I know it hasn't shown on my graph, but it says, it gives you, I'll just put it in anyway, 1, 2, 3, 4. So you can say between 1 and 2 it's accelerating, but it's constantly increasing, so between 2 and 3 the gradient's increasing, so the acceleration's increasing. That's all you need to say, is refer to gradient and the acceleration. The 2 marks are done there. So that was 2C. Skip one. Now we're on to 2D. It says each pendulum was completed in 1.4 seconds. So without even reading the question, we could put 1.4, 2.8 plus 1.4, 4.2, 5.4. Sorry, not 5.4. 5.6. Sorry, I don't know why I can't add 1.4, but never mind. So these are the seconds, and there's the swings. So that's not very good. Right. Obviously, I had put the 1.4 seconds, 2.8, 2.8, 4.2, 5.6 next to the table on page 7, even though we're on the other page. Just shows to the examiner, if they're reading it, that they think, oh yes, this student has understood what we've put on the question, and it's not just quickly try to rush through it. So it says, use a graph on page 6 to figure the speed of the trolley after it had travelled 3 metres. So we draw a line up to here, and that is about 2. See what they accept. It says at 3 metres. Yeah. See what sec. Give me a second and go through it. Get 2.7 metres and distance equal, v equals 2s over t, that's 5.4 over 4.2, and that gets us 1.3 meters per second. Now if you don't know about v equals 2s over t, I rearranged the equation, one of the CVAT equations, v equals u plus 2as, I think it was. Yeah, so that's the equation. I just rearranged it, put it in that formula, and it gets the velocity. Hopefully that's coming across as quite easy to you. That's the end of question 2. There you got your full 11 marks there, and we'll see you in the next question.